Hello everyone. Today we're going to continue with our discussion on recursion. So this is the second video about recursion. In the first video, we basically discussed the uh, basic concept of recursion, like what recursion is, and we understood that with kind of a toy problem. In this video, we're going to the formalize the discussion that we had in the previous videos and learn about a lot of technical terms and basically learn about how we can develop ourselves recursive algorithms. So let's start off with that. So a recursive algorithm starts off obviously with the problem, right? The problem that we want to try to solve, right? What a recursive algorithm does in the first step is break this problem down into smaller sub-problem. These sub-problems could be one or they could be more than one, as shown in this figure. After this problem is broken down into these smaller sub-problems, these sub-problems are somehow solved and the solutions of these sub-problems are obtained. Okay. Once we have the solutions of these sub-problems, the final step of the recursive algorithm is to combine these solutions to find a solution to the original problem, right? So this whole structure is the structure of any recursive algorithm. Now, a very basic, genuine doubt that comes is how do we find the solutions of these sub problems, right? How do we go from the sub problems to the solutions of the sub problems? And so there are two things that can happen, okay? In a recursive algorithm, there are two possibilities. The first one is that the sub problem that you have is a base case itself, right? What I mean by a base case is any case, any kind of input that you have for the problem, or any sub problem that is easy to solve, right? The solution to which is either very obvious or can be easily computed. Okay. So if you have a case like that, we simply either hard code the solution sometimes or write some simple algorithm to compute the solution to the base case, and that's it. So if the sub problem that you get is a base case, we have some easy method to calculate the solution to obtain the solution of the base case, and that's it. So we achieve the solution to the sub problem, right? But in the case that the sub problem isn't a base case, what can happen is that the sub problem is actually a smaller version of the original problem, right? uh, if the original problem had some big input numbers, the smaller problem, this sub problem, might be the exact same problem but with some smaller numbers, some smaller inputs. Okay. And this is a really, really important point. The problem cannot be different, right? A sub problem means that it's the same problem as the original problem, but just has smaller inputs or is of a smaller size. Okay. So if that is the case, if we have a smaller version of the original problem, then what we can do is we can use our original recursive algorithm that we were using for the original problem on this smaller problem also and find a solution to the smaller problem, right? What I mean by that is, if it's a little confusing, that we break this smaller problem into even smaller sub problems, okay, which are of the same type as of the original problem. We find the solutions to these sub problems, and then we combine the solutions to these smaller sub problems to find the solution to our smaller problem. Okay. Eventually, each of these sub problems is boiled down slowly and slowly to a base case, right? And you can have multiple base cases too. But eventually you keep breaking down the problem into smaller problems and smaller problems and smaller problems until you reach a base case. When you reach a base case, you have a way to find easy or obvious way to find the solution to that base case, and that's your solution to that sub problem. Then you use these solutions of base cases, and you combine these solutions slowly and slowly to build the solutions to your higher level problems, okay, to your little bigger problems, and then to problems that were bigger than that, and eventually you reach the solution of your original problem, right? So that's the whole concept and theory behind recursion, right? So to summarize, recursion has two things that it mainly does. It breaks a big problem into smaller and smaller sub problems till we reach a base case, and it uses the answers of these sub problems to create the answer of the original problem, right? So that's about recursion, and that's basically how any recursive algorithm that you'll ever see looks like, okay? But let's talk about the question of how would you yourself or I myself design a recursive algorithm upon seeing a problem, right? How? What do you need to design a recursive algorithm, right? So the first thing that you need to do, which I've mentioned as the 0th point here, is decide whether this problem can even be solved recursively, right? Is a recursive algorithm even a good idea to pursue in for this problem? And the questions that you need to answer for that is, firstly, can you break this problem into smaller pieces? If you can't break this big problem into smaller sub problems, then there's that'll help you. Then there's no way of pursuing a recursive algorithm. So that's the first question you need to answer. And the second question is that, does knowing the solutions of these smaller pieces, does knowing the solution of these small sub problems help you in getting the solution of the original problem? In other words, if you know the solution of these sub problems, can you in some way combine them to get the solution of the original problem, right? So if we answer both these questions positively, we can say that we can solve this problem recursively, right? Then comes the actual designing part. And the first thing we need to do in that is find out a way to break the big problem into smaller sub problems, right? It's very easy to say that we'll break this problem into smaller sub problems, but how is what you need to design, right? The questions you need to answer for that is, what exactly will be your sub problems that help you find the answer to this bigger problem, and how will you break this original problem into those sub problems, okay? That's the first step in designing a recursive algorithm. The second step is, once you've obtained just assume that you've obtained the solutions to these sub problems, how would you combine these solutions to get the solution of the original problem, right? Like, what operations should you do with these sub problems solutions, that like, in what manner should you combine them, join them, add them, subtract them, multiply? What should you do with them so that you combine them in some manner and eventually obtain the solution to your original problem, right? That's the second, and this is a very, very vital part of designing a recursive algorithm. And then comes the final part, the third part, which is also very important, that you need some base cases and their solutions. Because if you don't have these base cases, your recursion kind of never terminates, right? Because what we're doing is we're breaking the big problems down into smaller and smaller problems until you reach a base case. But if you forget about the base cases, if you don't have base cases, you'll just keep breaking down these problems down and down and down, and never ever be able to find the solution of even the smallest problem, right? So you need to find some base cases and find their solutions, right? So you can either like know about these solutions beforehand, either they would be obvious to you, or you can compute them easily using some easy commands or algorithms, right? So these base cases and their solutions should be designed by you again. And that's it. There are just 3 steps in designing the whole recursive algorithm. First, how do you break the problem into smaller subproblems? Second, how do you combine the answers of these smaller subproblems to get the answer of the original problem? And third, the base cases and the solutions. Okay. So I know this might seem very abstract and theoretical, but we'll move on to solving a problem now, and we'll follow these exact steps. Okay, and we'll keep referring to the concepts that we've discussed theoretically or abstractly till now, so that it really drives home the point. So the problem we're going to discuss is Fibonacci number. Now this is a very famous problem in computer science and mathematics. So the problem statement is that the Fibonacci numbers, commonly denoted Fn, form a sequence called the Fibonacci sequence, such that each number is the sum of 2 preceding ones, starting from 0 and 1. That is, f of 0 is 0, f of 1 is 1, and any f of n is equal to f of n minus 1 plus f of n minus 2 for n greater than 1. The question that we are asked is, given n, calculate f of n. So basically we need to calculate the nth Fibonacci number, and the definition of a Fibonacci number is given here, right? So let's try to write down a little bit of the Fibonacci sequence first to see what actually a Fibonacci number is, right? So it says that, let's say we write n here and f of n below it. So the 0th Fibonacci number is just 0. The first Fibonacci number is 1. The second Fibonacci number will be the sum of the 2 preceding Fibonacci numbers. So the sum of 1 and the sum of 0, which is 1, right? Then we have the third Fibonacci number, which will be the sum of the 2 preceding Fibonacci numbers, which means the sum of 1 and the sum of 1, which is 2, right? Similarly, the fourth Fibonacci number would be the sum of the 2 preceding Fibonacci numbers, which would be the sum of 2 with 1, which is 3, right? And so on. So that's how the Fibonacci sequence looks like. What we're asked to do is basically calculate the nth Fibonacci number for a given n, right? So the way to do that, so to figure out a way to do that using recursion, what we'll do first is start with an example. So let's say n is equal to 3 is given to us, right? Now what does this mean? This means that we need to calculate f of 3, right? Now if you look carefully at the definition of a Fibonacci number, f of 3 is nothing but f of 1 plus f of 2, right? Because f of n is equal to f of n minus 1 plus f of n minus 2, right? Which means if we calculate f of 2 and we calculate f of 1, like if we had these two values, we can basically add them to get f of 3, right? Now f of 1, if you look at the definition of a Fibonacci number, is 1, right? So we already know what this value is, so we can just so that's like the base case for our recursion, right? But f of 2 is not a base case. So what f of 2 is, according to the definition, is equal to f of 1 plus f of 0, right? Which means if we have f of 1 and f of 0, we can add these two numbers to get f of 2, right? And now if you see, f of 1 again is a base case, and so is f of 0, right? So f of 1 is basically 1 and f of 0 is 0, right? So this value is 1 let me just use another pencil. Yeah, so this value is basically 1, right? And this value is 0. So that means that to find f of 2, we need to basically add these two numbers, which means f of 2 is 1 plus 0, which is equal to 1, right? That's f of 2. And f of 1, we know, again, is a base case, which is just 1, right? So to find f of 3 now, we need to add f of 2 and f of 1, right? Which means that we need to add 1 with 1. That means that f of 3 is 2. Okay, and this matches the table that we were drawing before. You can compare the two numbers, it'll be the same, right? So this is how like given a number, we would go about kind of calculating what the Fibonacci what the nth Fibonacci number is, right? So where does recursion come into play here, right? So let's start off with the 0th question that we need to ask ourselves. Can we even use recursion here? Like, is a recursion solution something that we should pursue? Obviously, right? Because if you see f of n, if n is greater than 1, breaks down into two sub-problems, right? Like here, f of 3 broke down into the sub-problem of finding f of 2 and finding f of 1, right? F of 2 again broke down into the sub-problem of finding f of 1 and finding f of 0, right? This is a sub-problem because it's the exact same problem. We're still calculating the Fibonacci number. It's just for a lower value of n. It's just a smaller input, right? So right, the first part of the question that we needed to answer, can we break down the problem into smaller subproblems? Yes, we can, obviously. And the second part is, can we combine the solutions of these subproblems easily to get the solution for the original subproblem, right? We obviously can, because as you see here, we just need to add the answers for these two subproblems to get the answer for our original problem, right? Just by adding the answers for these two subproblems. For example, to find f of 3, we just added the answer of f of 2 with the answer of f of 1 and we got f of 3, right? So we have a way of combining the solutions of the subproblems in such a way that we get a solution to the problem. So both these kind of rules are satisfied, which means that definitely a recursive solution is something that we can pursue here, right? So let's try to build that recursive solution, right? So let's say we have some function called fib, which stands for Fibonacci, and the input to it is n, right? And this calculates the nth Fibonacci number, okay? So how would we go about calculating the nth Fibonacci number, right? The first thing that we need to do is figure out a way of how to break the problem into sub-problems, right? So that's not tough, right? Because we know that sub-problem 1 would just be fib of n minus 1, right? To calculate the nth Fibonacci number, we need the n minus 1th Fibonacci number based on the recurrence relation given in the question itself, this recurrence relation. To calculate fn, we need fn minus 1, and the other subproblem we need is fn minus 2, right? So subproblem 1 would be fib of n minus 1, and this, if you notice, is a recursive call, right? This function fib is being called in the function, in the body of the function fib itself, right? So that's a recursive call. Similarly, sub of 2 is equal to fib of n minus 2, right? So once we have the answers of fib of n minus 1 and fib of n minus 2 in these variables sub 1 and sub 2, the answer for our original problem, which is the second step in building a recursive solution, is that we need to combine these subproblems in some manner to get the answer to our original problem, right? And the way to combine it is given in the question itself. You just need to add the answers to these subproblems to get f fib of n, right? So we just add sub 1 plus sub 2, right? And we get the answer. And finally, we can kind of, just return this answer, right? The third thing that we need, which is very important, are the base cases, right? Because without base cases, this would never kind of terminate. Like you'll just continuously keep making recursive calls, and you'll never find a solution to even the smallest problem, right? So the base cases are given again in the question itself, which I'm circling here in yellow, right? If you see, these are the base cases, right? So these base cases should be checked before we move into these recursive calls, right? Which means that if uh, n is equal to 0, then what we need to do is simply return 0. This is a base case, right? And this is an example of a base case in which the answer is hard coded because it's obvious, right? The answer for n is equal to 0 is given in the question itself, so it's obvious, and we can just hard code it, right? Similarly, if n is equal to 1, then we need to return 1, right? Which is the second base case. So we have these two base cases here, and other than that, we have this portion, which is kind of a recursive portion of the algorithm, right? So that's it. We found all the three things that we needed to. We found we broke the problem down into sub problems. We found a way to combine those sub problems into to get the answer for the original problem, and we also put in our base cases, right? So that's our algorithm, our recursive algorithm to find the Fibonacci numbers, right? So let's test this out by coding it up. Okay, we're here on lead code, and this is the same problem that we discussed. So let's just try to code up the algorithm that we discussed now. The first thing you should do is kind of make your recursive helper function. So when we were discussing the algorithm, we called that fib, but here they've already given this function the name fib. So let's just call it fibo now, which takes a number n and returns the nth Fibonacci number, but it's a recursive function, right? Then the first thing we need to check if n is a base case or not. So if n is 0, then we just return 0, right? And if n is 1, then we just return 1, right? After this, we kind of move into the actual recursive portion of the algorithm. So if it's not a base case, then what we need to do is first break the problem into its sub problems. So the first sub problem is finding the n minus 1th Fibonacci number, and the second sub problem is finding the n minus 2th Fibonacci number, and that's it, right? So these function calls fibo n minus 1 and fibo n minus 2 will return the answers for the n minus 1th and n minus 2th Fibonacci number, and we'll store them in sub 1 and sub 2 respectively, right? After that, we need a way to combine the solutions to the sub problems to get the solution for our original problem, right? And the way we did that was just by adding it based on the definition of the Fibonacci number that's given here. So answer is equal to sub 1 plus sub 2, and in the end we just return answer as the nth Fibonacci number, right? So to solve this problem completely, like this is just a recursive function that we made, we'll need to kind of call it if we need to find the nth Fibonacci number. So this should work. Let's try to run it. Right. So all these sample cases are kind of accepted. Let's try to submit it to give it a final check. And yeah, it works pretty well. So that's the whole kind of implementation of our recursive algorithm. Right. So this whole video was basically about the formal description of recursion, like uh, how any recursive algorithm looks like, and then we moved into how to design a recursive algorithm for any kind of a problem that you see, right? You break the problem into sub problem. You first, do the zeroth step of figuring out if recursion is even a good idea here, and if it is, then you figure out a way to break the problem into sub problems. You figure out a way to combine the answers of the sub problem to get the answer of the original problem, and you figure out your base cases, right? So that's basically what this whole video was. It might seem a little confusing or a bit much, uh, but it'll seem much better with a little bit of practice. So yeah, that's all. Keep practicing, and thank